here's the next question, number 3. So here we have a match the following question. 4 very important theorems. We have Stokes Theorem, Gauss's Theorem, Divergence Theorem, and Cauchy's Integral Theorem. On the other side, we have 4 equations, each equation relating to a certain theorem on the left. Okay, so instead of just matching them, let's go through each theorem individually. Okay, the statement is very important, so with the statement comes the equation. So let's start with Stokes Theorem. So that's first. We begin with Stokes Theorem. Now Stokes Theorem says that the integral of a closed curve f, let's say f, okay, I'll write that down here. Stokes Theorem. Now the statement says if S is an oriented smooth surface, let S be an oriented smooth surface that is bounded by a simple closed boundary curve C with a positive orientation. Also, let F bar be a field vector. Now, in this case, here we have a closed integral C. Now, this is our closed boundary curve C of the field vector F dr equals to the surface integral of the curl of F ds. Now, you should be quite familiar with what curl is. Curl indicates delta cross A. Delta cross A is curl of F. So, integral C closed curve of F dr equals the surface integral of delta cross A ds. Now, if we compare this with the options given to us, we see here there is just the fourth option there is delta cross A. So we have an option with delta cross A there. So here A is just F. So if we equate that, it's A dl equals surface integral of delta cross A ds. So this is our right option, which means that Stokes theorem of P corresponds to number 4. So that covers our first theorem. Let's look at the next one, Gauss's theorem. Now, at times Gauss's theorem is also called as divergence theorem, but here we have that as an option as well. So let's be very careful, okay? So here we have next Gauss's theorem. Okay, now Gauss's theorem, the statement says that the total flux, the total electric flux through any closed surface surrounding a charge Q is equal to the net positive charge enclosed by that particular surface. Now, if we are to convert this statement into an equation, let's see now, the total electric flux through any closed surface surrounding a charge q. So this is a surface. So we have a surface, let's say the flux density here, d is the flux density, ds is equal to the net positive charge. So the summation of all the charges, q. Okay, so here q is the charge and here d is the flux density. So let's try and see where this equation is in our options here. The very first one. So we have closed surface integral d ds equals q. So with the options given, that's closed d ds equals q. This is our equation for Gauss's theorem. I hope this makes sense. So the next thing we have, the next theorem is divergence theorem. Let's write down the statement for the divergence theorem. Divergence theorem. Okay, so the statement is, let V be a region in space with a certain boundary. Let's call that boundary dV. Then the volume integral, of the divergence. Now the divergence is actually del dot f, dot product between delta and f, over V, over that certain region V, and the surface integral, of f over the boundary dV. Now dV is the surface, okay, of V, are related by, here comes the equation, they are related by the volume integral of divergence. So that's del dot f dot product dV equals dV integral dV. So this is the surface integral. Here we have volume integral. dV is surface integral f dA. Now if we correspond this to an equation, to one of the equations given to us in the options here, take a look. Now where do we have dot product? We have a dot product there in the third option, and the integrals also match. So we have volume integral on the left side and we have surface integral on the right. So that matches. So we have here volume integral del dot A dV equals surface integral of A ds. Here f is A, just the notation is changed, that's about it. So this is the equation for divergence theorem. Next, let's look at Cauchy's integral theorem. Now Cauchy's integral theorem works on an analytic function, a function being analytic. Now when you see the word analytic, it has to do with the Cauchy-Riemann equations. So we'll note that down now. Cauchy's integral theorem. Now the statement says, if a function f of z is analytic in some simply connected region, let's call that region R, then we have our equation, closed integral of f of z dz equals 0. Now, when we say a function is analytic, it is supposed to satisfy the Cauchy-Riemann equations. So, analytic is when f of z satisfies Cauchy-Riemann equations. Now, you're familiar with that. We have seen that in a couple of problems before. Dou u by dou x equals dou v by dou y, and dou u by dou y equals minus dou v by dou x. So we have our Cauchy integral theorem as well, where it is the closed integral f of z dz equals 0. And that matches with, let's see which option here, the second option. So we now have all our 4 theorems with all the 4 equations. So we have Stokes Theorem, which corresponds to number 4, Gauss's Theorem, which corresponds to number 1, Divergence Theorem is 3, and Cauchy's integral theorem is number 2. So which means option B is the right answer. Well, this is the solution, and I hope it has helped.